Welcome to solverfy.
Okay, so we're doing chapter 22, problem 49 here. And this says charge is distributed within a solid sphere of radius r0 in such a way that the charge density is a function of the radial position. So it's given as the charge density as a function of r is rho naught times r over r0. So if the total charge within the sphere is q, and is positive, what is the electric field everywhere within the sphere in terms of Q, R0, and R? Okay, so first we know that the symmetry of the charge distribution allows this to be calculated using a Gaussian spherical surface. So for a radius of r less than r0, the enclosed charge is going to be the integral of our charge density function times dV. So we can rewrite this in terms of just the radial distance because we know that the volume and rho only depend on the radial distance. So this now integrating from 0 to r, this is rho naught times r prime over r naught. And dV, when we're changing into dr, we pick up the 4 pi r squared. That's r prime squared and dr prime. So this becomes our integral now to solve for what the enclosed charge is, and we can actually just solve for this. So this becomes p naught over r naught times 4 pi integral from 0 to r of r prime cubed dr prime. If we integrate that, we get rho naught pi r to the 4th over r naught. So this is our charge enclosed as a function of r. So now we can write this in terms of the total charge. So we know that Q equals Q enclosed at r equals r naught. So that is rho naught pi r naught cubed. So if we want to write charge enclosed as a function of r, this now becomes the total charge as a function, or times r over r naught all to the 4th. Cool. So now we have the charge enclosed as a function of r and q. So let's add this new page here. We know Gauss's law is given as E dot dA. Since we have a spherical symmetric problem, we can use a spherical Gaussian surface and say that this is equal to E times the 4 pi r squared, the surface area of our spherical surface. And that equals Q enclosed as a function of r over epsilon naught. So our E now becomes Q over 4 pi epsilon naught times 1 over r squared times r over r naught to the 4th. Or we can write this better, Q over 4 pi epsilon naught r squared over r naught to the 4th. And this is E as a function of r. We see that it's positive, so we know that the electric field is pointing radially outward. Cool.